Okay, welcome to this session, and in this session we are going to discuss dot plot. As mentioned in this Discovering Computer Science book, dot plot is one of the method to find the similarity between two texts. So in dot plot we can associate one text with x-axis of the plot and another text with the y-axis. So it means that text 1 will be placed on x-axis while we can place text 2 on y-axis. And in dot plot we place a dot at a position on xy axis if the character or slice of text at index x in the first text is same as the character or slice at index y in the second text. In simple words, we will place a dot on xy axis if they are similar, and if they are not similar we will not put a dot. So we will put a dot on those xy values which are similar. So means more dots in this plot means more similarity between the text, and if we have no dot it means that the texts are not similar. Less number of dots means less similarity between the text, while lot of dots means lot of similarity between the text. So we have to capture those xy positions which are similar, and once you capture those xy positions we can simply plot dots at those xy data points. So let's move to Spider to implement this. So we already having this function which can compare my two strings, and it is giving me the count right now, which is 12. But this time I wish to plot a graph. Let's name this function as dot plot. Okay, I'm passing text1 and text2. Since we have to plot a graph, so I need to import this library matplotlib.pyplot. This is a visualization library which is available in Python, so I have to import this. And in order to plot this you need two lists, one for x-axis, another for y-axis. So I'm creating two blank lists, one for x-axis and second for y-axis, and in these lists I have to append the index values which are similar. Count is not required, so you can remove this. In this code I am capturing the index values which are similar, and I can store those index values in my list. So in list we have a function called as append, which is used to add value into the list. So at present x-axis is empty, but if the letter are same then I can append index 1 into x-axis, and same way I should append corresponding value of index 2 in y-axis. So this will populate my list. Since lists are populated, then I can call a function which is available in my pyplot library, this library. So in pyplot I have a function called as scatter, and in this scatter function I can pass my two lists, which is x-axis and y-axis. Let's call this function with these values, Whitman College and DAV College. So I think my code is complete. Let's run this. So you can see that I have a plot. These are the dots which indicate the similarity between these two texts. Okay, this is working fine. So let's play with this, and you can see that this time the similarity has been reduced and these are the dots. Let's run this for these two text. Yeah, you can see there is a lot of similarity, and this is my text 1, this is text 2, and my plot is able to capture this. Yeah, we can further improve this graph. You can see that 0 is not starting from this corner, it is actually starting here from here. I can specify the range for x-axis and I can also specify the range for y-axis. Now let us consider this improved version of the final code. Importing my desirable library, calling my improved function as .plot1, passing my text1 and text2. This is the docstring. In order to make this comparison case insensitive, I am converting my passed text to lowercase so that if there is some variation in the case, it should also be captured in the similarity. So I'm converting text1 into lowercase and updating back to text1, converting text to lowercase and updating back to text2, defining toList for x-axis and y-axis, running first loop for the length of text1, second loop for the length of text2. If the letters are same, then I am appending this to my desirable list. In X I am appending index 1, in Y I am appending index 2. Then just calling scatter function, it will scatter everything on X and Y axis. And you can see that I am using X limit function. You can specify the range for X axis. It will start from 0 and it will go up to length of text 1, while your y-axis again will start from 0 and it will go up to the length of text 2. And here I am assigning labels to my x-axis and y-axis. The label of x-axis will be text 1, the label of y-axis is text 2, and then just calling this show function of pyplot. So let's suppose these are my two text items. So my function name is .plot1. Let's run this. So you can see this is the final graph. Text 1, now it's starting from 0 to the length of text 1. This is to the length of text 2. So you can play with this and you can see it will capture all the similarities. So let's make text 1 as Whitman College, text 2 as DAV College. It has captured the similarity, and you can see the similarity is in the last part of both the text. Here I have Whitman College, DAV College. Let's add few more random text. Now this time you can see that similarity is somewhere in the middle, because in the end I have just added few junk characters which are not same. So similarity is not in the beginning, not in the end, but somewhere here in the middle. So I hope you got this point clearly, and this is about dot plot. So take your time to implement this. The code discussed in this video session is available in the description of this video, so you can directly implement this. Thanks for watching this video.